few figures in history have captivated the human imagination as profoundly as Leonardo da Vinci. Artist, inventor, scientist, and philosopher, his genius transcended disciplines, bridging the worlds of art and science in ways that continue to inspire awe centuries later. Yet, for all that is known about Leonardo, there remains a sense of mystery, a sense that some aspects of his brilliance were deliberately hidden from casual observers. Nowhere is this more evident than in his notebooks, a sprawling collection of sketches, calculations, observations, and musings. These pages offer the window into the mind of a genius, but they also contain a secret, a coded language, a method of concealing ideas, and a way of intertwining art, science, and philosophy that continues to puzzle scholars and enthusiasts alike. The notebooks of Leonardo da Vinci are not mere journals. They are a labyrinthine archive of human curiosity. They contain anatomical drawings that rival modern medical illustrations, designs for machines that would not be built for centuries, observations on flight, water, and geometry, as well as philosophical reflections on life, nature, and the universe. Yet the way Leonardo recorded his ideas was often unconventional. He wrote in mirror script, sometimes backwards, sometimes in seemingly nonsensical sequences of letters, numbers, and symbols. Many of his entries are fragmented, leaving gaps that tease the reader into discovering patterns, correlations, and hidden connections. It is as if Leonardo intended his notebooks to be puzzles, meant only for those patient and attentive enough to unlock their secrets. This script explores the secret code of Leonardo da Vinci's notebooks, shedding light on the genius's methods, intentions, and the ways in which he transformed ordinary observations into extraordinary insights. We will delve into the historical context of his writings, the peculiarities of his mirror script, the ingenious ways he used symbols, and the insights that can still be gleaned from his pages today. Along the way, we will explore not just the mechanics of the code itself, but the philosophy and mindset that underpin it, a reminder that Leonardo's genius was not just in what he saw, but in how he chose to record and organize his observations. The allure of Leonardo's secret code lies not merely in its complexity, but in the intimacy it offers between reader and genius. To study the notebooks is to enter into a dialogue with a mind that refused to accept the limits of conventional thinking, a mind that sought understanding not only of the material world, but of the principles that underlie it. Leonardo's writings challenge us to observe more closely, to think more deeply, and to appreciate the extraordinary patience and curiosity that define true discovery. In this exploration, we step into that labyrinth, not to solve every mystery, but to appreciate the depth, sophistication, and quiet brilliance that continues to make Leonardo da Vinci one of history's most compelling figures. Section 1. The Mystery of Leonardo's Mirror Writing. Leonardo da Vinci's notebooks are famous for many reasons. The exquisite artistry of his sketches, the breadth of his interests, and the clarity of his observations. Yet one of the most intriguing features is his use of mirror writing. The practice of writing from right to left, in reverse, so that the text appears normal only when viewed in a mirror. This distinctive style has inspired fascination and speculation for centuries. Scholars, cryptographers, and enthusiasts have pondered why Leonardo chose this method and what it might reveal about his thought processes. At first glance, the choice might seem eccentric or whimsical. Why not write as everyone else did? Several explanations have been proposed, ranging from the practical to the psychological. One practical explanation is that Leonardo, being left-handed, may have found it easier to write from right to left, preventing smudging of ink as his hand moved across the page. Indeed, the left-handedness of Leonardo is well documented, and his fluid, elegant script seems to support the idea that mirror writing allowed for a smoother, more efficient flow of penmanship. Beyond practicality, mirror writing may have served as a form of secrecy. Leonardo was aware that many of his ideas, especially mechanical inventions and anatomical studies, were revolutionary for his time. By reversing the text, he added a layer of protection, ensuring that only the most determined and knowledgeable readers could decode his notes. In an era before copyright or intellectual property, this was an ingenious strategy. Leonardo could explore radical ideas without fear of immediate imitation or ridicule. But mirror writing was more than just practical or protective. It was also deeply reflective of Leonardo's cognitive style. He often visualized his ideas as integrated systems, combining observation, imagination, and theory. Writing backward mirrored the way he thought, non-linear, multidimensional, and interconnected. In many ways, his mirror script becomes a metaphor for the mind that produced it, a mind that could see not just the surface of reality, but the underlying structures, patterns, and hidden principles that govern the natural world. To read Leonardo is to practice patience and perspective. The effort to decode his writing echoes the mental discipline he applied to observation and invention. In addition to mirror writing, Leonardo's notebooks feature a variety of symbols, shorthand, and inventive notations. Alchemical symbols, arrows, diagrams, and sketches are interspersed with text, creating a dense tapestry of information. Sometimes a single page contains multiple layers of meaning. Anatomical diagrams, annotated with observations on motion and function, coupled with philosophical reflections on life, mortality, and the nature of knowledge. The result is a multi-dimensional document that resists linear reading, requiring a careful and reflective approach to fully appreciate its depth. Interestingly, Leonardo sometimes combined mirror writing with playful linguistic tricks. Words could be fragmented across lines, phrases might overlap, and letters were occasionally substituted with invented symbols. This suggests that the secret code within the notebooks was not purely functional, but also expressive, reflecting Leonardo's delight in the interplay between language, thought, and representation. The act of reading his notebooks is therefore a collaborative experience. The reader becomes a partner in discovery, navigating the coded language, deciphering meaning, and uncovering insights hidden in plain sight. Modern scholarship has applied digital analysis, cryptography, and imaging technology to Leonardo's notebooks, revealing additional layers of meaning and organization. While some of the code remains mysterious, patterns emerge that suggest deliberate structuring. Leonardo's notebooks are not random jottings. They are carefully composed explorations of science, art, philosophy, and mechanics, designed to be both private and enduring. They illustrate a profound principle: that knowledge is both a personal journey and a shared endeavor, and that the process of recording, encoding, and reflecting can deepen understanding as much as the content itself. In sum, Leonardo's mirror writing is a key that opens not only his notes, but also his mind. It challenges modern readers to slow down, observe closely, and consider alternative perspectives. It reminds us that genius often disguises itself in subtle, playful, and enigmatic forms, inviting those willing to engage with patience and curiosity into a world of hidden knowledge. The mirror is not merely a tool for reading. It is a symbol of reflection, perception, and the layered nature of understanding. To study Leonardo's secret code is, in essence, to engage in a conversation across centuries with one of history's most extraordinary minds. Section 2. The Symbols, Diagrams, and Hidden Language of Genius. Beyond mirror writing, Leonardo da Vinci's notebooks are filled with a fascinating assortment of symbols, diagrams, and idiosyncratic notations that suggest a hidden layer of meaning beyond the literal text. Unlike ordinary note-taking, Leonardo's pages appear as an intricate tapestry of visual and verbal thought. He seamlessly blends images with text, creating a multidimensional record of his curiosity. Every stroke of the pen seems purposeful, hinting at ideas meant to be preserved, interpreted, or perhaps deliberately concealed. For modern observers, these symbols are not merely decorative. They are an essential part of understanding the man who could see patterns in chaos, systems in nature, and relationships in seemingly unrelated phenomena. Leonardo employed a variety of symbols, often unique to his own mental framework. He used arrows to indicate the direction of movement, circles and lines to signify geometric relationships, and shorthand notations to condense complex ideas into a single visual expression. For instance, in his studies of water currents and eddies, diagrams show spiraling lines that resemble both natural phenomena and abstract mathematical forms, demonstrating his ability to visualize patterns that others might only describe verbally. Similarly, his anatomical sketches often contain annotations that combine shorthand with descriptive labels, reflecting both meticulous observation and an intuitive grasp of function. These symbols were more than mere aids to memory. They were tools for thought, helping him to explore ideas that were too complex to capture in words alone. One of the most intriguing aspects of Leonardo's symbolic language is its potential role as a code. While mirror writing was a visible layer of secrecy, many scholars suggest that Leonardo embedded additional layers of meaning within his symbols and diagrams. Certain recurring shapes, arrangements, or combinations of letters may represent concepts or processes understood only by him. For example, the use of overlapping geometric forms in his architectural sketches could encode proportional relationships, mechanical principles, or even philosophical ideas about harmony and balance. Similarly, patterns of shading or line weight might indicate emphasis, hierarchy, or sequence, suggesting that the visual presentation of information was as important as the information itself. Leonardo's coding techniques may also reflect his fascination with the interconnectedness of knowledge. In the Renaissance, the boundaries between art, science, and philosophy were fluid, and Leonardo's work embodies this integration. By blending visual symbols with textual notes, he could simultaneously explore multiple dimensions of a problem. In his studies of flight, for example, anatomical sketches of birds are juxtaposed with engineering diagrams for machines designed to mimic their motion. Symbols such as arrows, circles, and lines connect the two domains, creating a visual map that links observation, theory, and invention. In this way, the notebooks function not only as records, but as a cognitive tool, allowing Leonardo to experiment, cross-reference, and synthesize ideas in real time. Some researchers have proposed that Leonardo's use of symbols may have deeper philosophical or esoteric significance. During his lifetime, codes, ciphers, and symbolic languages were often associated with alchemy, secret societies, and intellectual exploration. While there is no direct evidence that Leonardo belonged to a secret society, his notebooks demonstrate a fascination with hidden knowledge, transformation, and the underlying principles of nature. Certain alchemical symbols appear sporadically, and even the structure of his diagrams, circles within circles, spirals, and intersecting lines, echo the mystical geometry found in contemporary philosophical and spiritual texts. While these references may not indicate literal occult practice, they suggest a mindset attuned to layers of meaning beyond the immediately visible. Another unique feature of Leonardo's symbolic language is its capacity to transcend disciplines. Unlike modern note-taking, which often isolates categories of knowledge, Leonardo's notebooks are integrative. Botanical sketches sit beside mechanical calculations. Anatomical studies appear alongside notes on proportion and perspective. Musings on the flow of water merge with reflections on human motion. Symbols act as connective tissue between these domains, enabling him to see analogies and correspondences that others might miss. For instance, the study of a whirlpool might inform the design of a machine, while the movement of a human limb could inspire a principle in architecture. The symbols become bridges, enabling a holistic approach to understanding the world. It is also worth noting that Leonardo's codes were playful. Beyond secrecy and functionality, there is a delight in invention and observation. Certain symbols or arrangements seem whimsical, almost like puzzles left for future readers to unravel. Some pages include marginal sketches or annotations that do not directly relate to the main text, inviting engagement and exploration. This playfulness is consistent with Leonardo's personality as recorded by contemporaries. Curious, inventive, and deeply engaged with the world, yet always aware of the mysteries that lie just beyond human perception. Modern scholars have employed sophisticated tools to analyze these symbols, from digital imaging to pattern recognition software. These methods have revealed structural consistencies, recurring motifs, and even cryptic sequences that hint at internal logic. While much remains undeciphered, the results underscore Leonardo's brilliance. He created a system of knowledge that is simultaneously personal, complex, and enduring. His codes challenge readers to think visually, conceptually, and analogically, a reminder that true genius often resists simplification. In practical terms, the symbols in Leonardo's notebooks are a testament to his problem-solving approach. Rather than relying solely on text, he externalized thought into visual and symbolic form, creating a medium in which complex interactions could be tested, modified, and refined. This method allowed him to explore ideas that were far ahead of his time, from mechanical engineering to human anatomy, and to preserve insights that remain relevant today. His notebooks are thus both historical artifacts and cognitive experiments, tools that teach us as much about thinking creatively as about the content of his discoveries. Ultimately, the symbolic and coded elements of Leonardo da Vinci's notebooks are more than curiosities. They are an invitation to enter the mind of a genius. They demand patience, observation, and imagination, asking the reader to think in layers, to appreciate the interplay between visual and textual thought, and to recognize that knowledge is not always linear or immediately transparent. The pages are not just records of discoveries. They are living documents of thinking itself, capturing the mind that sought not merely to record the world, but to understand, transform, and interact with it on multiple levels. Leonardo's symbols remind us that knowledge is a journey, not a destination. Each diagram, notation, or coded element encourages reflection, curiosity, and exploration. They reveal a mind that delighted in mystery, challenged assumptions, and sought connections where others saw only isolated facts. In exploring these symbols, we glimpse the secret code of a man whose genius continues to resonate, centuries after his pen first touched paper. Section 3. The enigmatic mirror writing and its purpose. One of the most famous and visually striking features of Leonardo da Vinci's notebooks is his consistent use of mirror writing, a technique where words are written from right to left, reversed as if reflected in a mirror. At first glance, this peculiar habit seems like nothing more than a curiosity or eccentricity, but closer examination reveals layers of practical, intellectual, and possibly even personal reasoning. This mirrored script is perhaps the most iconic code associated with Leonardo, capturing the imagination of historians, scientists, and cryptographers for centuries. Mirror writing appears throughout Leonardo's notebooks, from mundane observations to profound theories. For example, he would record anatomical discoveries, engineering sketches, or philosophical musings in reversed text. To the casual observer, the text appears unintelligible. Yet with a mirror or careful mental reversal, the content is revealed in perfect clarity. This duality, simultaneously opaque and transparent, reflects a fascinating interplay between secrecy, cognition, and creativity. Unlike a traditional cipher, which replaces letters with arbitrary symbols, mirror writing retains the original letters, but flips their orientation. This simplicity disguises a sophisticated understanding of perception, demonstrating Leonardo's awareness of how humans interact with text and information. Several practical explanations for Leonardo's mirror writing have been proposed. One of the most common theories suggests that he wrote in reverse to prevent smudging. As a left-handed writer, Leonardo's natural motion from right to left would cause ink to smear if written in standard script. By writing backward, his hand glided over a blank portion of the page, preserving the clarity of his notes. While this explanation may seem mundane, it emphasizes Leonardo's meticulous attention to detail. Even his writing technique is optimized for functionality, reflecting a mind oriented toward efficiency and precision. Another plausible reason for the mirror writing is privacy. Leonardo's notebooks contain many observations that could be considered sensitive, particularly in the realms of anatomy, engineering, and military innovation. By employing mirror writing, he could obscure his discoveries from casual readers, apprentices, or potential rivals. In Renaissance Italy, intellectual property as we understand it today did not exist, and knowledge was a valuable commodity. Mirror writing, therefore, could function as a low-tech safeguard, ensuring that only those willing to decode the text or those aware of his technique could access the information. In this sense, it serves as both a shield and a statement of ownership over ideas. The mirror writing also aligns with Leonardo's fascination with perception and cognition. He was deeply interested in how humans observe, interpret, and internalize the world. By writing backward, he subtly challenges the reader to engage actively with his work, to reverse assumptions, and to reconsider familiar perspectives. The act of decoding becomes a participatory exercise, forcing the mind to adapt, interpret, and reconstruct meaning. In this sense, Leonardo's mirrored text is less about secrecy and more about interaction, an early demonstration of experiential learning, where the reader must engage physically and mentally to uncover the content. Beyond practicality and privacy, mirror writing may also have a symbolic or philosophical significance. Leonardo was a Renaissance polymath, blending art, science, and philosophy in his explorations. Writing backward could represent a metaphor for the hidden truths of the world, the need to look beyond the obvious, or the inversion of conventional thinking. Many of his sketches, whether of anatomical structures or mechanical devices, explore hidden systems and underlying mechanisms. Similarly, his mirrored script hints at a world in which truth is layered, perception is subjective, and understanding requires effort, reflection, and careful observation. The text itself becomes a miniature philosophical experiment, a coded meditation on the relationship between appearance and reality. Some scholars have suggested that mirror writing may reflect Leonardo's playful genius. He delighted in puzzles, riddles, and challenges, and his notebooks contain numerous examples of visual jokes, whimsical sketches, and thought experiments. Writing backward could be viewed as an extension of this playful intellectual style, a way of embedding a private amusement in his work. Unlike modern encryption, which is often purely functional, Leonardo's mirrored script engages both logic and creativity, revealing the joy he took in thinking differently. Each line written in reverse becomes a subtle invitation for engagement, teasing the mind to look closer, think harder, and uncover the secret within. Interestingly, mirror writing was not entirely unique to Leonardo, though few contemporaries used it as extensively. Historical records suggest that some other Renaissance figures, including scholars and scribes, occasionally employed reversed script for emphasis or decoration. However, Leonardo's application is unparalleled in its consistency, sophistication, and integration with visual elements. In his notebooks, mirror writing coexists with diagrams, sketches, and symbols, forming a seamless system in which text and image reinforce and elucidate each other. The mirrored text is part of a larger cognitive environment, a dynamic interface between thought and expression that defies conventional categorization. The enduring fascination with Leonardo's mirror writing also reflects the human attraction to mystery. For centuries, readers have speculated about hidden meanings, secret codes, or undiscovered knowledge embedded within his reverse text. While much of it is likely practical or playful, there remains the tantalizing possibility that certain sequences, combinations, or placements may encode subtler insights. Researchers have applied modern technology, including pattern recognition and digital analysis, to search for recurring structures, linguistic patterns, or numerical significance within the mirrored text. These investigations underscore the depth of Leonardo's genius. His work rewards meticulous attention, repeated study, and imaginative interpretation. Mirror writing exemplifies a broader theme in Leonardo's notebooks: the integration of mind and hand, thought and action, observation and expression. By reversing letters, he transforms a mundane act, writing, into a cognitive and creative process. Each line demands precision, focus, and awareness, reinforcing the connection between intellect and manual skill. This holistic approach is evident throughout his work, from anatomy to engineering, painting to cartography. His mirrored text is both a tool and a statement. It embodies the unity of thought, perception, and creation that defines his legacy. In conclusion, Leonardo da Vinci's mirror writing is more than a stylistic quirk. It is a multifunctional, multidimensional tool that reflects his ingenuity, practical intelligence, intellectual playfulness, and philosophical depth. It protects knowledge, engages the reader, experiments with perception, and aligns with broader patterns of thinking across his notebooks. Every mirrored word is a window into the mind of a polymath who was constantly exploring, challenging, and reimagining the world around him. The technique reminds us that genius often resides not only in what is discovered, but in how ideas are expressed and perceived. Mirror writing is an invitation, a challenge to look beyond the surface, to decipher hidden meaning, and to experience thought in its most intricate, layered form. In the mirrored pages of Leonardo da Vinci's notebooks, we are asked not merely to read, but to see, think, and imagine alongside one of history's most extraordinary minds. Section 4: Symbols, Diagrams, and Hidden Patterns. Beyond the mirrored script, Leonardo da Vinci's notebooks are filled with symbols, intricate diagrams, and abstract patterns that often appear cryptic to modern readers. These visual elements function as another layer of his secret code, intertwining observation, imagination, and analysis in ways that reflect both his artistic genius and his scientific rigor. While some of these symbols are straightforward, representing gears, anatomical parts, or water currents, many carry more enigmatic implications, hinting at ideas that are abstract, experimental, or deliberately obscured. One striking feature of Leonardo's symbolic language is the interplay between text and image. His notes rarely exist as isolated words. Instead, They are integrated with sketches that range from the minute to the monumental. For instance, when exploring the mechanics of flight, he often combines schematic representations of wings with numerical annotations and written hypotheses. The symbols in these diagrams are not random. They encode relationships, motions, and forces in ways that conventional text cannot fully capture. In essence, Leonardo's diagrams operate as visual equations, condensing complex scientific and philosophical concepts into forms that are simultaneously concrete and abstract. Leonardo frequently used geometric shapes and proportional diagrams to reveal underlying structures. Circles, triangles, and spirals appear repeatedly, illustrating ideas from mechanical advantage to human anatomy. One famous example is the Vitruvian Man, a diagram that maps the proportions of the human body within a circle and square. While widely recognized today as a study of human anatomy, it is also a symbolic exploration of harmony, mathematics, and cosmology. The concentric layers of information, numerical, spatial, and symbolic, demonstrate Leonardo's ability to encode multiple levels of meaning in a single visual form. These diagrams often require careful study to decode, reinforcing the notion that knowledge, to Leonardo, was both multidimensional and experiential. Hidden patterns in his work extend beyond geometry into repetition, symmetry, and subtle visual cues. Leonardo had a remarkable ability to detect natural rhythms, whether in flowing water, wind currents, or human motion, and he often translated these observations into schematic patterns. Spirals may indicate rotational flow, intersecting lines can represent structural stress, and overlapping curves may describe anatomical or mechanical relationships. These repeated motifs are not purely decorative. They serve as a kind of shorthand for complex phenomena. By encoding recurring principles in visual patterns, Leonardo created a system of knowledge that was modular, flexible, and efficient, a precursor to modern diagrammatic thinking. Some researchers argue that certain symbols in Leonardo's notebooks may have been intended as personal ciphers. For example, he occasionally combines letters with abstract marks or incorporates pictorial elements that are only meaningful in context. These hybrid forms, part alphabet, part drawing, suggest a layered system of communication in which the visual, textual, and symbolic intersect. While much of this may have been intended for his own use, it is also possible that Leonardo deliberately embedded misleading or obscure elements to protect his discoveries. In Renaissance Italy, where scientific and artistic knowledge could confer economic or political advantage, such protective ambiguity would have been practical as well as intellectually stimulating. The natural world itself provided Leonardo with symbolic inspiration. He was fascinated by plants, animals, and geological formations, often abstracting their forms into diagrams that simultaneously convey observation and concept. For example, the branching of rivers, the flow of air around sails, or the structure of muscles and tendons are rendered in ways that are both scientifically precise and visually patterned. These abstractions reveal a mind that sees beyond surface appearances, seeking underlying rules and harmonies. Symbols and diagrams thus act as bridges between the visible and the conceptual, allowing Leonardo to manipulate, explore, and predict natural phenomena. Another aspect of Leonardo's symbolic system involves numerology and proportion. He frequently annotates sketches with numbers, fractions, and ratios, often in combination with visual forms. These numeric annotations are rarely simple measurements. They often imply relationships between parts, scaling factors, or dynamic interactions. In anatomical sketches, for example, numerical ratios illustrate the proportional relationships between limbs, muscles, or organs. In mechanical designs, numbers may specify torque, leverage, or geometric alignment. Through these annotations, Leonardo encodes quantitative information in a visual and symbolic format, creating multi-layered diagrams that function simultaneously as art, science, and code. Some historians suggest that Leonardo's symbolic approach may also have had a mnemonic function. The human brain is highly responsive to visual cues, patterns, and associations. By embedding symbolic markers within sketches, Leonardo may have been developing a personal system for recalling complex sequences of observations or procedures. These symbols act as memory aids, encoding the logic of processes that would be difficult to retain solely through text. In this sense, his notebooks are as much cognitive tools as repositories of knowledge, reflecting a sophisticated understanding of how humans internalize, organize, and retrieve information. Leonardo's diagrams also blur the boundary between imagination and reality. Some sketches depict inventions or experiments that were never constructed, while others visualize concepts before they can be empirically tested. By using symbols, he abstracts essential principles from material constraints, allowing the mind to explore possibilities without limitation. The combination of empirical observation and imaginative projection is a hallmark of his creative method. Symbols condense observation into models, and models then extend into speculation. This iterative process, observe, abstract, model, imagine, is encoded within every diagram, revealing a mind that simultaneously records the known and anticipates the unknown. Finally, the presence of recurring motifs and coded sequences has fueled centuries of speculation. Researchers have debated whether Leonardo embedded hidden messages, religious symbolism, or philosophical allegories within his notebooks. Some propose that patterns in diagrams reflect esoteric knowledge, while others see them as an aesthetic or cognitive strategy. Regardless of intention, the interplay of symbols, diagrams, and abstract forms adds depth, complexity, and intrigue, making the notebooks a living puzzle that continues to challenge and inspire. In essence, the symbolic and diagrammatic elements in Leonardo da Vinci's notebooks are far more than mere decoration or technical shorthand. They are integral to his intellectual vision, a language that blends observation, abstraction, and imagination. Through symbols, he encodes natural laws, engineering principles, anatomical structures, and even philosophical reflection. Each diagram is a window into the way he thought, a visual representation of the interplay between mind and world. To study these symbols is to engage with Leonardo's reasoning, to follow the contours of a mind that seeks patterns, understands relationships, and delights in uncovering hidden harmonies. In conclusion, Leonardo's symbols and diagrams transform his notebooks from simple records into multi-layered intellectual landscapes. They invite readers to decipher, explore, and participate in the act of discovery, demonstrating that knowledge is not only to be read, but experienced. In combining text, image, number, and pattern, Leonardo created a system that is at once practical, aesthetic, and profoundly enigmatic. Through this interplay, his work continues to fascinate, offering insight not just into the Renaissance world, but into the workings of a singularly extraordinary mind. Section 5. The Language of Invention. Leonardo da Vinci's notebooks are not only repositories of artistic observation and anatomical study, they are also extraordinary records of invention. What distinguishes Leonardo's approach from other inventors of his time is the way he encoded his mechanical ideas into a private, symbolic language. Many of his sketches depict machines and contraptions that were centuries ahead of their time, from flying devices and hydraulic pumps to war engines and intricate automata. Yet these designs are almost always accompanied by a mixture of mirrored script, cryptic symbols, and abstract annotations that transform ordinary technical drawings into a form of secret communication. One fascinating aspect of Leonardo's inventive language is the integration of motion into static diagrams. He often used arrows, spirals, and overlapping lines to suggest movement, flow, or direction, indicating the intended mechanics of a machine without the need for extended textual explanation. For example, in sketches of early helicopter concepts, rotating mechanisms are depicted with interlocking circles and spiraling lines, while additional notations describe force, angle, and resistance. This combination of visual cues and numerical relationships allows the diagrams to convey dynamic processes, effectively making them animated in the mind's eye of the reader. Such representations were not merely artistic, they were functional tools for both conceptualization and construction. Leonardo's inventions also reveal a deliberate layering of information. A single page might include multiple variations of a concept, each exploring a different aspect of the same principle. For instance, his studies of water wheels show variations in wheel design, gearing, and channeling, while annotations provide data on rotation speed, torque, and fluid pressure. These layers operate like a complex code. Understanding the full design requires integrating visual, numerical, and textual elements. It is as if Leonardo was creating a private engineering language, accessible only to someone who could interpret the interplay between the symbols, measurements, and motion cues. In many cases, Leonardo's choice of symbols reflects a conceptual abstraction that extends beyond simple mechanical functionality. His flying machines, for example, frequently combine skeletal frames with diagrams reminiscent of human anatomy. By overlaying bird wings with mechanical levers and jointed structures, Leonardo not only documents his observations of nature, but encodes the principles of biomechanics in symbolic form. These sketches are simultaneously studies of biology, engineering, and physics, showing that Leonardo's inventive language was multidimensional. Each diagram is a compact representation of observation, analysis, and imaginative projection, where symbols stand for principles rather than purely objects. The secretive nature of Leonardo's notation has fueled speculation about his intentions. Some historians suggest that he deliberately obscured certain technical details to protect his inventions from misuse or theft. In Renaissance Italy, knowledge was both currency and power, and a masterful engineer like Leonardo would have understood the value of discretion. By encoding motion, proportions, and structural relationships in a symbolic language, he could explore complex mechanical concepts privately, recording innovations without revealing them entirely to potential rivals. These coded annotations may therefore represent both practical ingenuity and strategic caution. Leonardo also experimented with hybrid forms of notation that blur the boundary between text and image. In some sketches, letters and numbers are integrated into diagrams, serving as both identifiers and components of the mechanical system. In other cases, abstract shapes are used to mark points of stress, motion, or alignment, suggesting a symbolic shorthand that condenses detailed information into a form that can be quickly referenced. This hybrid language demonstrates Leonardo's deep understanding of how humans process information. He created diagrams that communicate simultaneously through sight, logic, and intuition. In effect, his notebooks are early examples of visual programming, where symbols operate as instructions for thought and action. Water and hydraulics were particular areas where Leonardo's symbolic language flourished. He studied the flow of rivers, the motion of currents, and the behavior of water in engineered channels, encoding his observations in diagrams that combined arrows, spirals, and proportional lines. These studies were not purely theoretical. They informed the construction of canals, mills, and fountains. Yet the symbolic complexity suggests that Leonardo was equally concerned with documenting principles as he was with producing working devices. The diagrams encode both empirical observation and inventive extrapolation, showing how symbols can transform simple sketches into conceptual laboratories for experimentation. Another fascinating element of Leonardo's inventive language is its use of repetition and variation. He frequently explored a single concept through multiple diagrams, each emphasizing a different parameter or functional aspect. By adjusting angles, dimensions, or connection points, he generated an array of solutions, revealing his methodical approach to problem solving. The symbolic repetition reinforces understanding while also acting as a subtle code. The pattern of variation communicates the rules governing the design, allowing the reader or the inventor himself to recognize underlying principles across different iterations. Some of Leonardo's inventions remain enigmatic, their purpose and operation still debated. For example, sketches of complex mechanical devices such as armored carts, multi-stage gears, or automated musical instruments contain symbols whose meaning is not entirely clear. Were these practical plans, speculative experiments, or exercises in intellectual play? The ambiguity adds to the sense that Leonardo's notebooks functioned as a private universe of inquiry, a place where symbols, diagrams, and annotations converge into a language of creativity that only he fully mastered. It is also important to recognize the aesthetic dimension of Leonardo's symbolic language. His inventions are not purely technical. They are imbued with a sense of harmony, proportion, and elegance. Diagrams often display a careful balance between form and function, with symbols arranged to create visual rhythm and coherence. This aesthetic sensibility reinforces comprehension, making the complex systems easier to understand and recall, while also reflecting Leonardo's belief that beauty and utility are inseparable. In this way, his inventive code is both practical and poetic, appealing to the mind and the eye simultaneously. Finally, Leonardo's symbolic approach to invention had lasting influence. Modern engineers, designers, and coders recognize the value of visual thinking and symbolic representation in problem solving. By combining observation, abstraction, and symbolic notation, Leonardo anticipated techniques that would not be formalized until centuries later. His notebooks reveal that invention is not merely the application of knowledge. It is the creation of a language for exploring possibilities, testing ideas, and communicating complex systems. In every diagram, symbol, and annotation, Leonardo's inventive mind speaks to us across time, inviting us to see, think, and imagine as he did. In conclusion, the language of invention in Leonardo da Vinci's notebooks is a remarkable fusion of observation, abstraction, and symbolic communication. Through diagrams, motion cues, numerical annotations, and hybrid symbols, Leonardo created a private system for recording and exploring mechanical principles. This inventive language allowed him to encode complex ideas, protect knowledge, and communicate in a multi-layered format that engages both intellect and imagination. Studying these symbols today is not only an exercise in historical curiosity, but a window into the mind of one of history's most extraordinary thinkers, whose ability to see connections between nature, mechanics, and human creativity remains unparalleled. Section 6. Nature as Cipher. Leonardo da Vinci's notebooks are not merely records of technical ingenuity. They are also deeply infused with his observations of the natural world. For Leonardo, nature itself was a language, a cipher that could be read, decoded, and ultimately applied to art, engineering, and invention. His fascination with the patterns, rhythms, and structures of nature led him to develop a symbolic system that translated natural phenomena into designs, mechanisms, and artistic representations, creating a bridge between observation and creation that was both empirical and imaginative. One of the clearest examples of this natural cipher is Leonardo's meticulous study of water. He observed streams, vortices, and the swirling motion of eddies with almost obsessive precision, often creating dozens of sketches for a single phenomenon. In these diagrams, arrows indicate flow direction, lines suggest force and speed, and spirals represent rotational motion. However, these are not mere depictions of what he saw. They encode principles of fluid dynamics in a symbolic shorthand. By turning motion and force into visual symbols, Leonardo created a language that could convey physical laws without relying solely on textual description. The sketches are at once scientific, artistic, and coded. They translate the ephemeral motions of water into a legible form that can inform engineering solutions. Leonardo's fascination with flight is another area where nature becomes a cipher. Inspired by the movement of birds and the structure of wings, he sought to understand the mechanics of lift and propulsion. His sketches of ornithopters and other flying devices are densely annotated with mirrored notes, symbols for angles and tension, and arrows indicating movement. These symbols encode lessons learned from nature: wing curvature, feather arrangement, and joint articulation, allowing Leonardo to translate the organic motion of birds into mechanical design. In essence, each sketch represents a decryption of natural principles into human-engineered structures, a translation from one language to another that required both observation and intuition. Botanical studies further demonstrate Leonardo's symbolic approach to understanding nature. He created detailed diagrams of leaves, flowers, and tree branches, noting patterns of growth, symmetry, and proportion. Many sketches reveal the use of geometric structures to map natural forms. Spirals of sunflower seeds, branching of trees, and leaf arrangements are rendered using grids, circles, and radial lines. These geometric overlays act as symbols, encoding the logic of natural design and highlighting principles such as the golden ratio, symmetry, and fractal-like repetition. In Leonardo's system, natural beauty is not arbitrary. It is a set of coded rules that can be observed, analyzed, and applied creatively. Leonardo's approach to anatomy similarly treats the human body as a cipher. He dissected cadavers and created highly detailed anatomical sketches, often accompanied by mirrored annotations and symbolic lines that indicate muscle direction, joint movement, and skeletal structure. These drawings serve a dual purpose. They are both empirical records and a symbolic map of the principles underlying human motion. For example, in his studies of the arm, Leonardo uses arrows and dotted lines to indicate the path of tendons and the rotation of joints, creating a visual code that conveys both structure and function. By decoding the body's mechanics, Leonardo could apply these insights to painting, sculpture, and mechanical design, demonstrating the interconnectedness of natural observation and inventive practice. Another intriguing aspect of Leonardo's natural cipher is his use of pattern and repetition. Many of his sketches display the same natural form in multiple iterations, each slightly altered to explore a different aspect: growth patterns, angles, force, or proportion. This repetition serves as a key to understanding the symbolic language. Variations highlight rules, constraints, and principles that govern the natural world. For instance, a series of sketches of waves or ripples might explore the interaction between gravity, momentum, and viscosity, with each diagram adding a layer of encoded information. The repetition not only deepens comprehension, but creates a visual rhythm that transforms observation into a language of predictive power. Leonardo also employed analogy as a coding method. He frequently drew parallels between seemingly unrelated natural phenomena, such as water flow, air currents, and human anatomy, to reveal underlying principles. By representing different systems with similar symbolic structures, he created a universal visual grammar that could be applied across disciplines. For example, the way water spirals around an obstacle could inform the design of gears or turbines, while the movement of a bird's wing could inspire mechanisms for lifting or rotation. This analogical thinking transforms the natural world into a multidimensional code where observation becomes insight and insight becomes invention. The symbolic representation of natural elements was not limited to mechanics. Leonardo also encoded aesthetic principles drawn from nature. Patterns of light, shadow, and perspective were carefully noted with lines, cross-hatching, and geometric markers, revealing a systematic approach to understanding and reproducing natural phenomena. In his sketches of landscapes, mountains, and rivers, symbolic cues indicate depth, direction, and scale. These visual symbols operate as instructions for the mind. They allow the observer to reconstruct motion, form, and space without physically interacting with the scene. In this way, Leonardo's notebooks serve as both a naturalist's field guide and a coded manual for creative expression. Interestingly, Leonardo often intertwined these symbolic representations of nature with his inventive designs. A single page might juxtapose a study of water flow with sketches of a hydraulic pump, or a bird's wing alongside a mechanical ornithopter. By encoding natural principles directly into technical diagrams, he created a seamless dialogue between observation and application. The natural world becomes both teacher and blueprint, a living code from which machines, artworks, and structures could be derived. The enduring fascination with Leonardo's notebooks lies in this interplay between secrecy and revelation. While some symbols remain enigmatic, many are understandable with careful analysis, revealing an extraordinary mind capable of bridging art, science, and invention. The code of nature he developed is at once precise and poetic. It translates the language of the external world into a personal system of knowledge. Ultimately, Leonardo da Vinci's use of nature as a cipher demonstrates a unique cognitive strategy. He saw the world as a set of rules, rhythms, and patterns waiting to be decoded. His notebooks are a record of this translation process, where observation, symbolism, and invention converge. By encoding the natural world, Leonardo created a system that not only advanced understanding in his own time, but continues to inspire scientists, engineers, and artists today. Each sketch is an invitation to read nature not just as a spectacle, but as a language, a code of beauty, function, and interconnection. Section 7. The Language of Machines. Leonardo da Vinci's fascination with machines was inseparable from his studies of nature, anatomy, and mathematics. For him, machines were not mere tools. They were extensions of natural principles, constructed through careful observation, analogy, and symbolic representation. In his notebooks, Leonardo developed a visual language to describe mechanisms, a system that translated motion, force, and function into a coherent and often cryptic code. This language of machines, like his representations of nature, allowed him to communicate ideas that words alone could not convey, preserving the logic of motion in a form that could be read by those initiated in his methods. A central aspect of this mechanical language is the use of arrows, lines, and geometrical shapes to indicate motion, force, and direction. Leonardo's sketches of gears, pulleys, and wheels are annotated with these symbols, which show not only how the machine should be constructed, but how it is intended to operate. For instance, in diagrams of a compound gear system, curved arrows illustrate rotational direction, while straight lines denote force vectors or the path of a moving component. By encoding these dynamic aspects visually, Leonardo could convey both structure and function simultaneously, making his notebooks living diagrams of movement. One of the most striking examples of this symbolic language is Leonardo's work on gear-driven mechanisms. Unlike simple gear sketches, which only show teeth and meshing wheels. Leonardo's diagrams include multiple layers of coded information. Rotation speed, torque, and force distribution are indicated through repeated symbols, concentric circles, and line thickness. These annotations turn a static diagram into a dynamic blueprint, a machine that can be understood not only in how it looks, but in how it behaves. This approach is astonishingly modern. It prefigures engineering schematics that would not become standard for centuries. Leonardo's fascination with motion extended to the human body as well. He often drew analogies between mechanical systems and anatomical function, creating a kind of hybrid symbolic language that merged physiology with engineering. For example, the bending of an arm might be represented alongside a lever mechanism, with lines showing force transmission and rotational angles. Similarly, the contraction of muscles and tension of tendons could be mapped to spring-like devices, demonstrating a profound understanding of mechanics at both micro and macro scales. This approach illustrates Leonardo's genius. He saw humans, animals, and machines as systems governed by the same principles, all of which could be described through his symbolic code. Another significant element of Leonardo's mechanical language is his treatment of water-driven machines. He designed complex hydraulic devices, including pumps, water wheels, and locks, often accompanied by diagrams of natural water flow. In these sketches, arrows indicate current direction, spirals denote turbulence, and shading represents force gradients. By encoding both the machine and the natural force driving it, Leonardo created diagrams that simultaneously convey environmental context and mechanical design. This holistic approach is unique. It treats machines not as isolated devices, but as part of an interconnected system, a reflection of his broader philosophy that all phenomena, natural or artificial, are part of a unified order. Leonardo also used symbolic shorthand to communicate timing, sequence, and causality in mechanical systems. In automata and self-moving devices, he employed numbers, dotted lines, and repeated symbols to indicate the order of operations, durations of motion, and interactions between components. For example, in sketches of a self-propelled cart, arrows show wheel rotation, while additional lines indicate the path of gears, levers, and springs that coordinate movement. This system allows the observer to mentally animate the machine, to visualize its motion step by step, even without constructing it physically. In essence, Leonardo's diagrams are a kind of mechanical storytelling, where symbols narrate the behavior of objects through time. Interestingly, Leonardo's language of machines was deliberately obfuscated in places, likely as a form of intellectual property. By writing notes in mirrored script and using symbolic annotations, he made his designs accessible primarily to those who could decode his methods. This secretive approach ensured that his inventions remained his own. Yet it also reflects a deeper philosophy. The act of decoding was part of understanding. To read Leonardo's machines correctly, one had to engage with them actively, translating symbols into motion, contemplating the interaction of forces, and imagining the system in operation. The code was not only protective, it was pedagogical, training the mind to think in terms of dynamic relationships rather than static objects. Leonardo's automata, in particular, highlight the sophistication of his mechanical language. His designs for mechanical lions, birds, and humanoid figures are full of arrows, lines, and symbols indicating joints, levers, and springs. Each movement, whether the lift of a paw or the flutter of wings, is encoded visually, showing both intent and method. These designs are not merely whimsical, they represent an early form of robotics, where symbolic representation allows for conceptual testing before physical construction. Leonardo's notation transforms imagination into a systematic, almost computational process, demonstrating the deep integration of creativity and engineering in his thinking. Moreover, Leonardo's mechanical symbols often incorporate lessons from natural observation. The spiraling motion of water, the leverage of a bird's wing, or the tension in human tendons are all translated into mechanical analogs. This synthesis of biology, physics, and engineering underscores a recurring theme in his notebooks: the interconnectedness of all systems. By reading his machines alongside his natural studies, one can see how each symbol functions on multiple levels, describing movement, indicating force, and linking the artificial to the natural. The machines are not isolated inventions. They are extensions of the same logic that governs the world around them. Finally, Leonardo's mechanical diagrams demonstrate an early understanding of modular design. He often drew individual components, gears, cams, pulleys, on separate sketches, fully annotated, and then recombined them into larger systems. The symbolic language allows for this recombination. Arrows, lines, and geometric markers communicate how pieces fit and interact, making it possible to adapt and scale designs. This modular approach is remarkably advanced, anticipating principles of modern engineering and manufacturing, where components are standardized, interchangeable, and reconfigurable. In conclusion, Leonardo da Vinci's notebooks reveal a profound and intricate language of machines. By encoding motion, force, sequence, and function through symbols, diagrams, and mirrored notes, he created a system that transforms observation into invention. His mechanical language is at once practical, poetic, and deeply intellectual, enabling the mind to visualize, predict, and manipulate complex systems. It demonstrates a seamless integration of art, science, and engineering, revealing a genius who could not only observe the world, but translate it into an enduring, dynamic code, a code that continues to inspire curiosity, ingenuity, and wonder. Section 8. Secrets behind Leonardo's anatomical drawings. Leonardo da Vinci's fascination with the human body was unparalleled in his era. While most artists of the Renaissance focused on surface appearance, Leonardo sought to understand the inner workings of anatomy, exploring muscles, bones, and organs with meticulous attention to detail. His anatomical drawings are more than scientific studies. They are a visual language, a secret code combining observation, artistic representation, and cryptic notation. Each sketch carries layers of information, simultaneously conveying structure, function, and motion, often hidden within mirrored writing or symbolic annotations. These drawings demonstrate Leonardo's revolutionary approach. He treated the body as both an aesthetic form and a complex machine, subject to the same mechanical principles he applied to gears, pulleys, and automata. One of the most remarkable aspects of Leonardo's anatomical code is the integration of movement into his illustrations. Unlike static diagrams, His sketches often depict how muscles contract, how tendons pull, and how joints articulate. Arrows, lines, and shading are used to indicate direction of force, the range of motion, and the dynamic interaction between parts. For example, in his studies of the shoulder, Leonardo carefully notes the rotational capacity of the arm and the interplay of the rotator cuff muscles, using curved lines to show vectors of movement. This visual encoding allows the observer to mentally animate the human body, almost like a three-dimensional blueprint, centuries ahead of modern biomechanics. Leonardo's attention to proportion is another layer of his secret language. He meticulously measured body parts and their relationships, often creating grids or geometric references to ensure precision. These proportional studies reveal his interest in symmetry, balance, and harmony, not merely for artistic beauty, but for mechanical accuracy. By embedding measurements and geometric indicators within his sketches, he encoded the mechanics of life itself, demonstrating a holistic understanding of anatomy as a system governed by natural laws. This approach mirrors the methods used in his engineering studies, suggesting a continuous thread between his exploration of machines and his exploration of the human body. Furthermore, Leonardo frequently employed cross-sectional views in his anatomical studies, a technique almost unheard of in his time. By cutting through organs or limbs in his drawings, he revealed internal structures while maintaining the context of surrounding tissues. These cross-sections often include subtle symbolic annotations, dots, hatches, and lines that signify depth, density, or function. For example, in his study of the heart, Leonardo not only sketches the chambers and valves, but annotates the direction of blood flow with arrows and shading, effectively creating a dynamic map of circulation, long before the scientific understanding of the circulatory system was formalized. Leonardo's anatomical sketches also contain a coded approach to observation. He used mirrored writing in many of his notebooks, possibly to keep his studies private or to protect his intellectual property, but also as a mnemonic device. This mirrored script transforms ordinary notes into a puzzle that requires active engagement, encouraging readers to slow down and decode the information. In essence, the code is pedagogical. It forces one to think like Leonardo, to analyze relationships between form and function, and to internalize the logic behind his discoveries. Reading his anatomical notes is therefore both the scientific and intellectual exercise, a way to inhabit the mind of one of history's greatest thinkers. Another striking feature is Leonardo's blending of art and science. He never separated aesthetics from anatomical accuracy. Rather, he used beauty to clarify function. Muscles are rendered not only with precision, but with attention to curvature, light, and proportion, creating a visual flow that guides the eye through the mechanics of the body. This dual purpose of clarity and artistry makes his work uniquely communicative. It explains, instructs, and inspires simultaneously. Every line, every shade, every symbol is intentional, forming a silent language that communicates across centuries. Leonardo's studies of the skeleton also demonstrate his coded approach. He frequently annotated bone lengths, angles, and articulation points, often using letters or symbols to connect different parts of a diagram. These markings are subtle but crucial, They reveal his systematic method for understanding posture, gait, and leverage. By mapping skeletal movement in this way, Leonardo essentially created early musculoskeletal diagrams that predict how humans could move, lift, and balance. This level of insight reflects not only artistic curiosity, but also engineering logic. The body, like any machine, follows the principles of motion and force. Moreover, Leonardo's anatomical notes often include experimental observations. He dissected cadavers to verify hypotheses about muscle function, blood flow, and organ positioning. These empirical experiments are documented with sketches that combine direct observation with theoretical projections, showing layers of reality in parallel. Arrows, numbering systems, and side notes indicate sequences of dissection or hypothesized movements. This layering of direct observation and deductive reasoning forms a sophisticated system of knowledge representation, encoding complex biological truths into a form both visual and symbolic. An intriguing dimension of Leonardo's anatomical code is his approach to pathology. He often sketched diseased or malformed organs, annotating deviations from normal structure. This allowed him to study not only ideal anatomy, but also anomalies, creating a comprehensive visual lexicon of human biology. Symbols and shading highlight areas of concern, while comparative sketches demonstrate variation between individuals. By documenting irregularities alongside typical anatomy, Leonardo codified variability, implicitly teaching how function might differ under different conditions, a principle that anticipates modern medical illustration. Leonardo also connected anatomy to mechanics in his drawings of the head and brain. He studied the skull not as a fixed shell, but as a mechanical housing for delicate systems, including muscles, blood vessels, and the brain itself. Using lines, arrows, and shading, he mapped the interaction of jaw muscles, eye movements, and neurological pathways. His sketches of ventricles and cerebral structures include annotations suggesting rotational and fluid dynamics, blending observation with speculation. This fusion of mechanics, anatomy, and visual coding exemplifies the breadth of his thinking. He treated the human body as a dynamic, interconnected machine, and encoded it in a system of symbols that transcends time. Finally, Leonardo's anatomical drawings serve as a testament to his holistic vision. Each image is multi-layered, simultaneously artistic, scientific, mechanical, and pedagogical. They embody a language of observation and deduction, using arrows, lines, mirrored text, symbols, and shading to communicate motion, function, and proportion. The complexity of this code is staggering, yet it is carefully structured, allowing a determined observer to unlock the logic behind each sketch. In these pages, Leonardo encoded centuries of knowledge in a private visual language, one that continues to intrigue, inspire, and educate today. In conclusion, Leonardo's anatomical drawings are far more than artistic studies. They are a secret code, a visual and symbolic system designed to capture the mechanics of life itself. His integration of motion, measurement, experimentation, and aesthetics created a language that conveys both form and function, a system of knowledge hidden in plain sight. By studying these drawings, one not only appreciates the genius of their creator, but also gains insight into a mind capable of unifying art, science, and invention. A mind that communicated across time through the silent, elegant language of anatomy. Section 9. Leonardo's ciphers in engineering and machines. Leonardo da Vinci's notebooks are renowned for the complexity and brilliance of their mechanical studies. Yet, beneath the sketches of gears, pulleys, and contraptions lies a hidden layer of communication, a secret code that intertwines engineering knowledge with his desire for intellectual privacy. Unlike most inventors, Leonardo encoded his mechanical insights with a combination of mirrored writing, symbolic annotations, and visual cues, allowing his observations to remain private while creating a self-contained system of understanding. This code was not merely for secrecy. It was a tool for organizing thought, a way to map the logic of machines in a manner that transcended language and reached toward pure comprehension. Leonardo's fascination with machines is evident in his detailed sketches of flying devices, war engines, water-lifting pumps, and automata. Every illustration is accompanied by annotations in his characteristic mirrored script, but also includes arrows, lines, and numbered steps that indicate sequence, force, and movement. By combining textual and visual codes, Leonardo created a multi-dimensional representation of mechanics. For instance, a sketch of a rolling cart may include arrows showing torque distribution, hatching to indicate friction points, and numbers linking components in the order of assembly. To the casual reader, these notes might appear cryptic, yet they form a cohesive language that communicates both structure and function simultaneously. One of the most striking examples of Leonardo's coded engineering is found in his flying machines. Long before the principles of aerodynamics were formalized, Leonardo experimented with designs for ornithopters, gliders, and vertical lift devices. His sketches are annotated not with plain description, but with symbols representing forces, weight distribution, and wing curvature. Lines radiate outward to indicate tension and compression. Dotted paths suggest the intended trajectory of movement. Small letters or symbols mark critical points for adjustment. The combination of mirrored text and symbolic notation allowed him to embed theoretical understanding alongside practical instructions, creating a secret code for those capable of decoding the language. Leonardo's war machines, from catapults to multi-barreled cannons, reveal another layer of this coded methodology. Here, arrows indicate the direction of force, hatches suggest areas of stress or vulnerability, and proportions are annotated with geometric references to maintain balance. Each machine is both an invention and a puzzle. It represents a physical concept while encoding the calculations and reasoning behind it. In some sketches, multiple iterations of a single machine are layered atop one another, requiring careful observation to untangle, demonstrating Leonardo's penchant for compressing vast amounts of knowledge into a single visual field, a living archive of experimentation and refinement. Another fascinating aspect of Leonardo's mechanical code is the integration of nature and biomimicry. He often observed natural systems, birds, water currents, the muscular motion of animals, and abstracted these into mechanical principles. For example, in sketches of water wheels or pumps, he maps the flow of water using curved arrows and shading to indicate pressure points, translating organic movement into mechanical logic. Similarly, his studies of birds' wings are annotated with lines, hatches, and mirrored text describing lift, weight, and pivot points. This approach demonstrates that Leonardo's code was not merely descriptive. It was a language of analogy, using symbols and diagrams to draw connections between the natural world and human innovation. Leonardo also embedded a temporal element in his mechanical drawings. Certain sketches include numbered steps or sequences, often in mirrored writing, that show the process of assembly or operation. These sequences function as both instructions and encoded reasoning. They indicate which components interact first, how energy is transferred, and how mechanical forces propagate through a system. In a sense, these coded sequences are the precursors to modern flowcharts or schematics, yet they are infused with artistic sensibility. The placement of lines, arrows, and symbols is not random. It is carefully orchestrated to guide the eye through a conceptual journey, enabling the reader to mentally simulate the functioning machine before ever building it. Leonardo's use of proportional coding is another critical element. Measurements are often embedded subtly within diagrams, linked to specific components via letters or symbols. This allows him to convey dimensions and ratios without relying solely on written units, a method that makes his notebooks self-referential and self-contained. Proportional coding ensures that designs could be reconstructed accurately, even if the textual explanation was inaccessible or misunderstood. In essence, Leonardo created a universal mechanical language, one that transcended conventional verbal instruction and relied instead on spatial, visual, and symbolic comprehension. His notebooks also reveal a sophisticated approach to redundancy and error checking. Multiple sketches of the same device, often slightly different, are layered on a page, each annotated with variations in lines, shading, or mirrored text. These variations act as embedded commentary, offering alternative solutions or highlighting potential points of failure. This iterative process suggests that Leonardo treated his notebooks as a laboratory of ideas. Each sketch is a coded record of experimentation, observation, and correction. To decode these pages is to enter a mind that is simultaneously analytical, creative, and deeply systematic. Leonardo's automata studies further illustrate the depth of his coding. He designed mechanical lions, moving figures, and self-operating devices, often with layers of internal gearing and levers indicated only through symbolic shorthand. Arrows, curves, and hatching convey motion, tension, and energy transfer, while mirrored annotations describe function, intent, or timing. Unlike textual instructions, these codes are immersive. They allow the reader to see the machine in operation, to understand the interaction of parts without physically assembling them. In doing so, Leonardo created a visual simulation, a pre-digital method of modeling and experimentation. In addition, Leonardo occasionally embedded moral or philosophical reflections within his mechanical sketches, another layer of secret coding. Comments on balance, harmony, or the imitation of nature serve as both intellectual framing and symbolic guidance. In some drawings, seemingly innocuous lines or symbols may represent ethical or aesthetic principles guiding the design, reminding the reader that Leonardo saw machines not merely as functional objects, but as extensions of natural and human order. This blend of mechanics, philosophy, and art exemplifies the richness of his encoded systems. They are technical manuals, philosophical treatises, and works of art simultaneously. Finally, Leonardo's mechanical codes exemplify a timeless quality. While centuries have passed since his sketches were made, modern engineers, artists, and scientists still find themselves decoding these notebooks, discovering insights that remain surprisingly relevant. The combination of visual encoding, symbolic annotation, and mirrored text demonstrates a method of thinking that transcends time, a way to communicate complex ideas across generations using intuition, observation, and symbolism. Leonardo's notebooks are not merely historical artifacts. They are a living testament to the power of encoding knowledge in multiple dimensions, merging science, art, and invention into a language that continues to challenge and inspire. In conclusion, Leonardo da Vinci's mechanical sketches are far more than technical drawings. They are coded systems of knowledge, blending mirrored text, symbolic notation, arrows, shading, and proportional measures into a comprehensive visual language. His engineering codes document motion, force, assembly, and function, while also embedding philosophical and artistic principles, creating a multi-dimensional system of understanding. To study Leonardo's machines is to engage with a mind that thought in multiple layers simultaneously, a mind capable of seeing the world as a complex, interconnected system, and encoding that vision in a language that continues to mystify and educate centuries later. Section 10. Hidden Messages in Leonardo's Anatomical Studies. Leonardo da Vinci's fascination with the human body is legendary. Yet his anatomical notebooks are more than detailed studies of muscles, bones, and organs. They are a coded map of observation, philosophy, and secrecy. While scholars often focus on the precision and artistry of his dissections, there lies a subtler, almost cryptographic layer, wherein Leonardo embedded messages that extend beyond anatomy into the realms of knowledge protection, philosophical reflection, and even artistic experimentation. These coded elements illustrate his desire to understand not only the mechanics of the body, but the interconnectedness of life, art, and science. At first glance, Leonardo's anatomical sketches are meticulous records of dissections. The heart's chambers, the muscular layers of the arm, the skeletal framework of the hand. Yet closer inspection reveals that he often wrote his notes in mirrored script, requiring a reflective surface to read them. This mirrored writing, a hallmark of his notebooks, functioned both as a security measure and as a cognitive tool, helping him to process complex information in a method that was intuitive yet deliberately private. Scholars have long debated whether Leonardo's mirrored writing was purely practical, a technique to avoid smudging ink while writing left-handed, or whether it also encoded layers of meaning for a select audience capable of reading it. Beyond mirrored text, Leonardo developed a symbolic system to annotate his anatomical studies. Small letters, arrows, and geometric figures often accompany each sketch, creating a multi-dimensional understanding of motion, function, and proportion. For example, in his studies of the human arm, arrows indicate the direction of muscle contraction, while circles and lines denote rotational axes of joints. These symbols were not just instructional. They represent Leonardo's vision of the body as a mechanical system in which each part interacts harmoniously with others. In effect, his annotations function as both engineering schematics and philosophical commentary on human physiology. One particularly intriguing aspect of his anatomical coding is the layering of visual information. Leonardo often drew multiple iterations of the same body part on a single page, overlapping sketches to illustrate movement, cross-sections, or comparative anatomy. In these overlapping sketches, he occasionally obscured certain lines or included subtle variations in shading, requiring careful observation to interpret correctly. This technique may have served multiple purposes, protecting the sensitive knowledge from casual readers, allowing him to compress extensive information into a small visual space, and creating a kind of visual meditation where repeated study of the page reveals deeper insights over time. Leonardo's studies of the heart exemplify this layered approach. He dissected and sketched the organ from numerous angles, illustrating blood flow, valve function, and muscular contraction. In many sketches, mirrored text describes the physiological function, while lines and arrows map the movement of blood and pressure. Additionally, he included geometric overlays that relate the heart's structure to the proportions of the human body, and even celestial harmonics, revealing his belief in a correspondence between the microcosm of the human body and the macrocosm of the universe. This blending of empirical observation and symbolic encoding demonstrates the breadth of his thinking, where science, art, and philosophy are inseparable. Leonardo's anatomical codes extend beyond muscle and bone into the study of the brain and sensory organs. In sketches of the eye, for instance, he diagrams the lens, retina, and optic nerve with astonishing detail, while arrows indicate the path of light and visual processing. His annotations include symbols to indicate focus points, curvature, and motion, effectively encoding the dynamics of vision into a visual language. Similarly, in studies of the brain and nervous system, he combined labeled cross-sections with mirrored annotations and abstract symbols to map the flow of information, linking physical structures to cognitive function. It is almost as though he was creating a secret atlas of human perception. A remarkable element of Leonardo's anatomical coding is the integration of art into science. Many of his sketches include contour lines and hatching that serve dual purposes. They model form and volume while simultaneously encoding functional or symbolic information. For example, a series of shaded lines on a bicep may indicate not only muscle curvature, but also the relative tension during motion, providing a visual guide to movement. This synthesis of artistic technique with coded scientific insight allowed Leonardo to communicate complex ideas in a way that is accessible both to the eye and the mind, creating a language that operates across multiple layers of perception. In addition to the purely technical aspects, Leonardo often embedded philosophical commentary in his anatomical studies. Notes in mirrored text or alongside coded symbols reflect on the relationship between human anatomy, the mechanics of the natural world, and the divine. For instance, in some sketches of the skeleton, he annotates the symmetry and proportion of bones, subtly emphasizing harmony and balance as central to both bodily function and aesthetic beauty. These reflections suggest that his anatomical coding was never purely practical. It was an exploration of the human condition, blending empirical observation with metaphysical inquiry. Leonardo's approach also demonstrates an early understanding of abstraction and modeling. By encoding anatomical knowledge into visual symbols and layered sketches, he created a system that allowed ideas to be manipulated mentally before physical experimentation. This method resembles modern conceptual modeling, in which complex systems are represented abstractly to test hypotheses and predict outcomes. Leonardo's notebooks reveal that he understood the value of abstraction. Using encoded symbols, mirrored text, and overlapping sketches to simulate and explore human anatomy long before the advent of digital or computational tools. Furthermore, Leonardo occasionally encoded subtle warnings or hints within his anatomical pages. Certain sketches, particularly those dealing with surgical or dissection techniques, include small annotations indicating potential errors, vulnerabilities, or limitations. By encoding this information visually and textually, he ensured that only a careful reader, capable of deciphering the code, would fully understand the risks and nuances. In this way, the anatomical notebooks functioned as a guide, a cautionary manual, and a philosophical treatise, all encoded in a multidimensional visual language. In conclusion, Leonardo da Vinci's anatomical studies are far more than detailed records of human biology. They are a complex, coded language that integrates observation, symbolism, philosophy, and artistic mastery. Through mirrored writing, symbolic notation, layered sketches, and integrated artistic techniques, Leonardo encoded not only the mechanics of the human body, but also his reflections on harmony, perception, and the interconnectedness of life. Decoding his anatomical studies allows us to glimpse the depth of his intellect, revealing a mind capable of perceiving multiple layers of reality simultaneously and translating them into a language that continues to captivate and challenge centuries later. Section 11. Leonardo's Mathematical Codes and Proportions. Leonardo da Vinci's notebooks are a labyrinth of imagery, text, and secret symbols, but one of the most fascinating layers lies in his mathematical coding. For Leonardo, numbers were not merely tools for calculation. They were instruments of insight, a language through which he could decode the world. His obsession with proportion, geometry, and symmetry is evident throughout his work, from architectural sketches to anatomical studies, and yet these elements are far more than practical guides. They form a hidden framework that encodes principles of harmony, balance, and universal order. Understanding these mathematical codes provides a window into Leonardo's mind and his approach to integrating art, science, and philosophy. At the heart of Leonardo's mathematical coding is his use of geometric principles to structure both text and imagery. In many pages, he overlays anatomical sketches with geometric figures such as circles, squares, and triangles, using them to align body parts with specific proportions. The Vitruvian Man is perhaps the most famous example, illustrating the human body as a microcosm of universal harmony, with limbs aligned precisely to geometric relationships. While this drawing is often celebrated for its beauty and symmetry, it also functions as a coded system. Each proportion is carefully calculated to reflect both the mechanical efficiency of the human body and the aesthetic ideals derived from classical mathematics. Leonardo's fascination with the golden ratio is evident across his notebooks. This irrational number, approximately 1.618, had long been associated with beauty, balance, and natural order. Leonardo incorporated the golden ratio not only in his artistic compositions, but also in his anatomical studies, using it to structure the relationships between bones, muscles, and organs. In some sketches, subtle markers and divisions indicate proportional calculations, often coded through a combination of numeric annotations, mirrored text, and geometric overlays. These coded ratios suggest that Leonardo believed in a mathematical unity underlying all forms of life, a principle that could be observed, analyzed, and perhaps even mastered. Numbers and measurements in Leonardo's notebooks also functioned as mnemonic devices. By encoding specific ratios, angles, and distances through visual or symbolic means, he created a system that allowed him to remember complex relationships without relying solely on written text. For instance, repeated geometric patterns or sequences of marks may correspond to specific anatomical lengths or angles, creating a visual shorthand that could be deciphered with study. This approach transformed each page into a layered system, simultaneously serving as a record, a study tool, and a coded repository of knowledge. Leonardo's mathematical codes extend beyond the human form into mechanical and architectural systems. Many of his sketches of machines, such as gears, pulleys, and bridges, are annotated with numeric ratios and geometric diagrams. While these annotations are functional, they also reveal an aesthetic dimension. Leonardo's devices were designed according to the same principles of proportion and harmony that governed his art and anatomy. In this sense, his mathematical coding is not merely technical, it is philosophical, reflecting a worldview in which mathematics is the invisible architecture of nature itself. One particularly intriguing aspect of his mathematical system is the use of numeric symbolism. Certain numbers recur in multiple contexts across his notebooks, often associated with harmony, balance, or cosmic order. For example, sequences of numbers might indicate specific geometric divisions, while others may serve as symbolic references to philosophical or spiritual ideas. The deliberate repetition of certain numeric patterns suggests that Leonardo was embedding layers of meaning beyond immediate function, inviting a careful reader to decode these hidden messages. Leonardo's exploration of perspective further demonstrates his sophisticated use of mathematical coding. In architectural sketches and landscape studies, he employs vanishing points, converging lines, and proportional grids, often overlaying these calculations with mirrored notes and geometric symbols. These perspective studies are not just exercises in visual accuracy. They encode principles of perception, distance, and spatial relationships, reflecting Leonardo's understanding that seeing the world correctly requires both measurement and interpretation. In this way, mathematics becomes a language through which the physical, visual, and cognitive dimensions of reality can be harmonized. The integration of time and motion into his codes also reveals Leonardo's genius. In sketches of moving bodies or mechanical devices, he often includes sequences of measurements, angles, and repeated forms to indicate motion across time. These coded sequences act as both instructions and models, allowing Leonardo to anticipate movement, predict outcomes, and test ideas conceptually. It is a precursor to modern computational modeling, in which abstract systems of numbers and symbols simulate dynamic processes. Leonardo's use of numeric and geometric codes in this context demonstrates an almost scientific rigor, blending observation, experimentation, and abstract reasoning into a single integrated system. Leonardo's mathematical coding is closely tied to his interest in astronomy and the cosmos. In several notebooks, he sketches planetary orbits, celestial spheres, and star charts, embedding measurements and geometric relationships that reflect his understanding of celestial mechanics. These studies often echo the proportions he applied to the human body and machines, suggesting that he viewed the universe as an interconnected system governed by the same laws of proportion and harmony. By encoding these observations numerically and geometrically, Leonardo was essentially creating a universal language, one capable of describing both the microcosm of human anatomy and the macrocosm of celestial order. The aesthetic dimension of Leonardo's codes cannot be overstated. His geometric overlays, numeric annotations, and proportional grids were designed not only to convey knowledge, but to create visual and intellectual beauty. Each page of his notebooks is carefully composed, with lines, symbols, and numbers arranged to guide the eye, balance the composition, and reveal patterns over time. This meticulous attention to aesthetic coding reflects Leonardo's belief that understanding and beauty are inseparable, and that the act of observing or creating is itself a form of intellectual and spiritual engagement. Ultimately, Leonardo's mathematical codes serve multiple functions. They are tools for scientific investigation, mechanisms for memory and study, philosophical reflections on harmony and order, and aesthetic compositions in their own right. By embedding these codes across anatomy, art, mechanics, and astronomy, Leonardo created a multi-layered system that rewards careful study and offers insight into the integrated nature of his thought. Each symbol, line, and number is part of a network of meaning, demonstrating that Leonardo's genius was not simply technical or artistic. It was a profound attempt to perceive and describe the hidden architecture of reality. In conclusion, the mathematical codes in Leonardo da Vinci's notebooks reveal a mind that perceived the world in layers, where numbers, geometry, and proportion were intertwined with philosophy, art, and observation. These codes allowed him to explore the universe with rigor and creativity, to encode knowledge in ways that protect and enrich it, and to create a system of understanding that resonates across centuries. By studying these codes, we glimpse a man who sought not only to observe, but to decode the laws of existence. leaving behind a legacy of intellectual depth that continues to challenge and inspire. Section 12. The hidden language of Leonardo's margins. Among the most intriguing aspects of Leonardo da Vinci's notebooks is his use of marginalia, the notes, sketches, and cryptic symbols that often appear in the edges and corners of his pages. While margins are typically reserved for commentary or supplemental information, Leonardo transformed these spaces into a canvas for hidden communication, intellectual exploration, and experimentation with a personal code. By carefully examining these marginalia, scholars and enthusiasts can glimpse how Leonardo organized, encrypted, and layered his knowledge, offering insight into his extraordinary mind. Leonardo's margins often serve multiple purposes simultaneously. In some cases, they are structural tools, used to define the boundaries of a page, separate different topics, or create a visual hierarchy of information. Lines, boxes, and geometric frames demarcate sections, effectively guiding the reader's eye while providing subtle cues about the importance or order of the content. This organizational strategy is consistent across his notebooks, suggesting that Leonardo's concern with clarity and readability extended beyond the main body of his notes into every inch of the page. Even in the densest sketches, the margins offer a subtle rhythm, balancing visual density and ensuring that complex ideas remain navigable. More fascinating, however, is the encrypted quality of some marginalia. Leonardo frequently wrote in mirror script, a left-handed, backward style that can only be read correctly when reflected in a mirror. While mirror writing may have served practical purposes, reducing smudging with ink and accommodating left-handed writing, it also functions as a layer of secrecy. When applied to the margins, this technique allows Leonardo to conceal supplementary thoughts, personal observations, or speculative ideas from casual readers. A cryptic note tucked into a margin could carry experimental hypotheses, philosophical musings, or reflections on natural phenomena, all hidden in plain sight. Beyond mirror writing, Leonardo's marginalia sometimes incorporate symbols, diagrams, and shorthand notations that encode information both visually and numerically. Tiny sketches of gears, skeletal fragments, plant structures, or architectural details are often accompanied by numerical sequences or geometric marks that indicate measurement, proportion, or sequence. These marginal sketches are not mere doodles. They are an integral part of Leonardo's system of learning, enabling him to compress complex ideas into compact, portable formats. The margins become repositories for concentrated thought, allowing him to connect visual patterns, measurements, and written ideas across different domains. Another striking feature of Leonardo's margins is their dialogue with the main text. Often, marginal notes function as extensions of the central content, providing clarifications, alternate perspectives, or additional experiments. For example, an anatomical study of the heart might be accompanied in the margin by diagrams illustrating fluid dynamics, blood pressure, or mechanical analogs in water systems. These marginal additions show that Leonardo viewed knowledge as multidimensional, with main text and marginalia operating in a networked relationship rather than a linear one. By encoding this dialogue visually and numerically, he created a layered narrative in which readers could explore multiple pathways of understanding. Marginalia also reflect Leonardo's habit of cross-referencing ideas. Many pages contain arrows, lines, and numeric markers that link observations in the margins to other sketches, studies, or notes. This approach anticipates modern hypertext and digital annotation, where information exists in interconnected nodes rather than sequential order. Leonardo's margins, in essence, function as a map of his intellectual landscape, with each symbol and note pointing to broader patterns of thought that span anatomy, mechanics, mathematics, and natural philosophy. In this sense, the margins are not peripheral. They are central to understanding the full scope of his insights. The aesthetic qualities of Leonardo's marginalia are also noteworthy. He carefully balanced the visual weight of sketches and notes, often leaving white space or creating symmetrical arrangements that complement the main content. This attention to visual composition reflects his belief that beauty and clarity are inseparable, even in marginalia. The margins, while technically peripheral, are crafted with the same meticulous care as his central drawings, suggesting that Leonardo saw every inch of the page as a medium for both thought and art. Interestingly, some marginalia appear to contain philosophical or esoteric symbolism. In several notebooks, small marginal sketches depict unusual plant forms, geometric patterns, or symbolic figures that seem disconnected from the main text. Scholars speculate that these may represent metaphorical or spiritual ideas, encoded in visual shorthand. By placing them in the margins, Leonardo created a layer of meaning accessible only to those willing to look closely, blurring the boundaries between empirical observation and philosophical reflection. This subtlety highlights his dual commitment to rational inquiry and imaginative exploration, revealing a mind that sought to reconcile the observable world with the hidden patterns that underlie it. Leonardo's use of marginalia also demonstrates his iterative approach to learning. Many sketches and notes in the margins appear as experiments, ideas tested, revised, and sometimes abandoned. By confining these exploratory attempts to the edges of the page, he could document his thought process without interrupting the flow of the main narrative. Over time, these marginal experiments become a chronicle of intellectual development, showing how hypotheses evolved, mistakes were analyzed, and solutions emerged. The margins, in essence, serve as a laboratory for the mind, a space where curiosity, trial, and reflection coexist. In addition, the marginalia reveal Leonardo's habit of integrating multiple disciplines. On a single page, one might find anatomical sketches, mechanical diagrams, numerical calculations, and mirrored philosophical musings, all annotated in the margins. This interdisciplinary layering reflects his conviction that knowledge is interconnected, with insights from one domain illuminating another. The margins are the spaces where these intersections are most visible, revealing a mind that resisted compartmentalization and instead embraced complexity, ambiguity, and synthesis. Finally, Leonardo's marginalia offer clues to the personal and private dimensions of his thought. Some notes appear to be reminders, reflections, or musings intended only for himself, demonstrating a deeply introspective side. These private annotations, hidden in plain sight at the edges of the page, suggest that Leonardo's notebooks were not just repositories of universal knowledge, but also intimate spaces where he recorded his personal inquiries, doubts, and discoveries. The margins, therefore, are both public and private, bridging the visible and hidden aspects of his intellectual life. In conclusion, the margins of Leonardo da Vinci's notebooks are far more than decorative or functional spaces. They are repositories of encoded knowledge, blending mirror writing, numerical sequences, geometric patterns, and symbolic imagery to create layered, multi-dimensional records. Through marginalia, Leonardo extended the boundaries of each page, weaving a dialogue between the main text and the periphery, integrating multiple disciplines and embedding both practical and philosophical insights. To study these margins is to witness a genius at work, a mind that sought to understand, encode, and transmit the secrets of nature, art, and the human spirit. Leonardo's marginalia are, in many ways, the hidden heartbeat of his notebooks, a subtle, intricate, and endlessly fascinating testament to the depth and complexity of his thought. Section 13. Unlocking Leonardo's Legacy. As we reach the final section of our exploration into Leonardo da Vinci's notebooks, it becomes clear that the true marvel of these documents lies not just in their content, but in the method and mind of the man who created them. Leonardo's genius was inseparable from the way he recorded and encoded his observations, whether through mirror writing, layered marginalia, cryptic symbols, or complex diagrams. Each page is both a scientific study and a personal diary, a visual puzzle and a philosophical reflection, blending art, science, and intuition in a way that still captivates and challenges scholars centuries later. One of the enduring legacies of Leonardo's notebooks is their ability to inspire multiple interpretations. Scholars from diverse fields, anatomy, engineering, art history, cryptography, and philosophy, have all approached these pages with the hope of uncovering hidden meanings. In doing so, they have revealed a mind that deliberately blurred the boundaries between disciplines. Unlike many modern scientists who compartmentalize their work, Leonardo embraced a holistic approach. Physics informs art, anatomy informs mechanics, and observations of nature inform philosophical reflections. His notebooks are a testament to the power of interdisciplinary thinking. Demonstrating that creativity and knowledge thrive when ideas cross-pollinate. The margins and codes throughout Leonardo's work invite readers into an active dialogue with the text. Unlike conventional books, where information flows linearly from beginning to end, Leonardo's notebooks demand engagement. The reader must decode, connect, and interpret, moving between sketches, marginal notes, and mirrored passages. This interactive quality turns the act of reading into a participatory experience where understanding is co-created between author and observer. In this way, Leonardo's legacy is not merely the content of his discoveries, but the method of exploration itself, a model for curiosity, critical thinking, and lifelong learning. Furthermore, Leonardo's use of codes and hidden messages in the notebooks reflects a deeper aspect of his character. His awareness of the fragility of knowledge and the necessity of protecting it. In an era when intellectual property had no formal protections, and the dissemination of radical ideas could provoke censure or danger, encoding his thoughts allowed Leonardo to preserve knowledge while controlling access. The mirrored writings, encrypted diagrams, and esoteric symbols provided a form of intellectual security, ensuring that only those willing to engage deeply and thoughtfully could access his full insights. The notebooks also reveal Leonardo's deep connection with observation and experimentation. While many of his contemporaries relied primarily on text or illustration alone, Leonardo combined both methods in layers of meaning. A sketch of a water flow may be annotated with calculations, philosophical musings, and symbolic references, all arranged in the margins and across pages. Each element informs the others, creating a dynamic web of understanding. In this way, Leonardo anticipated modern systems thinking, showing that complex phenomena are best approached not in isolation, but as interconnected systems. Another remarkable feature of the notebooks is their timeless appeal and mystery. Despite centuries of study, many aspects of Leonardo's work remain unresolved. Scholars continue to debate the meaning of particular diagrams, the function of certain machines, or the symbolism in his sketches. The fact that these questions persist is not a limitation, but a testament to the notebook's richness. Leonardo designed them as living documents, meant to provoke inquiry, reflection, and discovery across generations. This open-endedness ensures that his legacy is never static. Each reader becomes a participant in the ongoing process of unlocking knowledge. The aesthetic and artistic qualities of Leonardo's notebooks cannot be understated. Beyond their intellectual content, the pages are works of art in their own right. The interplay of line, shadow, proportion, and layout demonstrates Leonardo's belief that beauty and understanding are inseparable, even in the most technical diagrams or experimental sketches. The elegance of his presentation communicates as much as the content itself. Observing a page is not just an intellectual exercise, it is also a visceral experience, connecting the observer to Leonardo's creative mind. Ultimately, the true wonder of Leonardo's notebooks lies in their humanity. They are not polished treatises, but living records of a man deeply curious about the world, recording his successes, failures, questions, and insights. The margins are filled with experiments that didn't work, sketches that were never completed, and thoughts that reveal both doubt and brilliance. This combination of rigor, creativity, and vulnerability is what makes the notebooks eternally compelling. They are a mirror of a human mind striving to understand the universe. In conclusion, Leonardo da Vinci's notebooks are far more than historical artifacts or artistic treasures. They are windows into the cognitive world of one of history's greatest minds. From the margins to the center of each page, from mirrored scripts to coded diagrams, every element reflects a deliberate method, a creative approach, and a philosophical vision. They demonstrate how curiosity, interdisciplinary thinking, and meticulous observation can combine to produce insights that transcend time. By studying these pages, we not only uncover the genius of Leonardo, but also gain inspiration for how to engage with the world, with patience, attention, and an unquenchable desire to discover.